Phragmites australis is an invasive subspecies from Europe. It's a nuisance around the world and was introduced to Utah around 1980. It's a poor habitat for native wildlife, and the Utah Department of Natural Resources is attempting to remove the plant from the state. Our primary objective is to produce a classified map of Phragmites with reasonable accuracy. The study area is in the Howard Slaw Waterfowl Management Area in Davis County, Utah. And you can see it right here at the red dot in relation to Ogden and Salt Lake City. The data were collected by a fixed-wing unmanned aerial system, pictured here, and it captures a multispectral image. So it has 5 bands: blue, green, red edge, and near infrared. And this plot here shows the reflectance response from different plant species. So the red line here is Phragmites, and then the white and the green line are 2 other native species. And then these vertical lines show where the image sensor is capturing its images. So the original image was quite large, and it was in the TIFF file format. Due to limits in training data and time, the image was cropped to be quite a bit smaller. So this here shows the different images captured by the sensor. So we have the red, green, blue, red edge, and near infrared. And this is a true color composite right here. So this is what you would see with your eye. And something to notice here is that the near infrared band has much higher reflectance than the red. So we can use a normalized index to highlight the different vegetation species in the image. So the training data were office interpreted due to limited access to the wetland, and we used ArcGIS Pro to create over 3,000 images and label masks in the RCNN mask format. I will now hand it off to Greg to explain how our classifier works.
Approximately 3,000 images that we can use for training. We then split these into a train and test set and prepare them as input for a TensorFlow model. We decided to use the UNet convolutional neural network architecture as pictured here. This is made up of an encoder and decoder, where the input image tile is brought into a high-dimensional space where areas of interest can be highlighted, then decoded into an output segmentation map of equal quality. To go over our workflow, we have this initial satellite image. We then tile this image to create an image collection pictured here. Then we run these 32 by 32 by 5 images through the segmentation app to get segmentation masks. Thereafter, we take the masks and map them back to the original image to create location-based mappings. To take you quickly through this program, we can load some images, a test and a train image, then rebuild our model using weights from the TensorFlow model base, then visualize our result. And what we can see here is that we do pretty well on the training data, achieving an accuracy of 89.5%. Furthermore, in the test set, we have an accuracy of approximately 86%. Some limitations we do want to cover are both the accuracy and the ability to take images of different dimensions. With more data, we believe the accuracy is bound to improve, whether this data be synthetic or created by hand. Additionally, we should be able to make some pre-processing adjustments to do dimension so the program can take multiple different types of dimensions.